Very often on your AP test, rather than lists of data, you may be given a regression computer output like we've seen before, but asked inference questions. That's going to involve us looking at the numbers we have traditionally ignored. So let's just do a review of what we've already known. So here's the output, looking at the explanatory variable of calories and the response variable of grams of protein in a random sample of 16 sandwiches. The regression equation, take a look over here next to the calories, since that's our x, there's your slope. So our slope is 0.06515, and above that at the constant, there's your y-intercept. So our regression equation, y hat equals 0.6515x, or protein, minus 4.308. Now, earlier in the year, I told you we're basically going to ignore all this stuff. Now is when we pay attention to this stuff. If you're asked to do a hypothesis test, that's what these numbers at the end are for. The 3.25 is your test statistic on this hypothesis test. It's always beta 1 equals 0, so slope equals 0, versus not equal 0. So it's always a two-sided test, giving us this p-value, which is 0.006, very, very tiny. So hey, guess what? Your test is pretty much done. You've got all the information you need. Don't make it complicated. Now, because we had 16 sandwiches, that puts us at 14 degrees of freedom. You would still list your test stat, your p-value, and decision, and then answer any questions that are asked. So because that p-value was low, we do have strong evidence to reject the null hypothesis, and thus have convincing evidence of a significant relationship, because a slope indicates that x and y are related, between the calories and the grams of protein in similar sandwiches. Now, you would need other information to check the conditions for inference. Sometimes the question itself may even say, assume the conditions for inference are met. That just means you don't need to do that check. But you should still list hypotheses, check conditions if they're not already done for you, give the same information, and there you go. Now, this isn't on the AP curriculum, but if you look right above it, it's the same thing. This is a test statistic that the y-intercept is 0, and here's the p-value on the test as well. So is 0 versus is not 0. We just don't have that on the AP test. That's why we're not going to address it further. So there's hypothesis tests from the computer output. What about confidence intervals? This is a little trickier. You're going to have to do some manual work. Here's the exact same output, but this time we are asked to construct a 95% confidence interval for beta 1. I need you to remember the setup for a confidence interval. It's always the same. It's the value you start with, so your sample statistic, the 0.06515, plus and minus a critical value, which we will have to find, times the standard error of the coefficient, which it just gives you right here, so that you don't have to figure that at all. The only number you don't currently have is that critical value. When we're talking about slopes, you're going to use t's, and your degrees of freedom is n minus 2, where n is your number of points. So 14 degrees of freedom, two ways to get this number. One is to use your formula sheets. Take a look at your t distribution. The confidence level would be at the bottom. I just didn't copy the whole page, but for a 95% confidence level and 14 degrees of freedom, 2.145. You can get this same number from your calculator if you prefer. You would just do an inverse t. So I want my distribution menu, second bars, inverse t. And then put in the area to the left of your cut. Here's where it gets a little tricky. If we got a 95% confidence interval, that means that that extra 5% gets divided amongst the two tails. So that's 2.5% on the high end, 2.5% on the low end. The area below that top cut is therefore 1 minus 2.5%, which is 97.5%. And degrees of freedom is 14. Paste it in, enter, and you're going to get that same 2.145 number. So whether you prefer the calculator or the chart, go nuts, make your choice. Now it's a matter of plug and chug. So the sample slope, plus and minus, critical value, times standard error of the coefficient, And there you have the 95% confidence interval for the true slope of this regression line. Interpret with 95% confidence the true regression slope that relates calories as the explanatory to grams of protein as the response is between a 0.02 and a 0.11. So the interpretation the same as it's always been. And there you have it. That is what you would need to know about inference on regression slopes. I wish you the best of luck.